This video is point estimate, margin of error, and determining the sample size. And our learning target is I can model and solve problems using point estimate, margin of error, and sample size. Okay, so let's just go over a few things. So point estimate is any statistic in a point. Any statistic is a point estimate. Okay, an example, the sample mean X bar is a point estimate for the population mean mu. So look at the example. And a researcher collects GPAs from a random sample of 30 AP Stat students. Find the point estimate for the population mean mu. So all you're going to do is you're going to add all these together, and you're going to divide by 30 because that's how many there are. So you can pause the video and do that, but you should get 3.42. So that is the point estimate. Okay, let's look at some more stuff. Margin of error. So margin of error is the amount that a stat may differ from the actual. So it's the difference from the actual. Because remember, anytime you take a sample, it's not the entire population, it's just a select few. And so the actual statistic may differ a little, and that's called a margin of error. So, example, the results of a survey shows that candidate A is leading with a margin of error plus or minus points, because you could go above or be below what you actually find. So we could take a sample of high school seniors to determine the number of students who are taking calculus. We could calculate a point estimate, such as mean, standard deviation, etc. We calculate a margin of error so that the sample estimate will not differ from the true population value. Okay, so for the formula, I'm just going to abbreviate margin of error as MO. And here's the formula. So it's plus and minus 1 divided by the square root of n. Okay, and then n is the sample size. Alright. And then sometimes you'll actually use this formula, which is point plus and minus z, then standard deviation over the sample size. Okay, and note that this one can only be used when the sampling distribution is normal. Okay, so I'm going to give you two examples of when we would use each formula. Okay, so the first one, we're taking a survey of 144 people. Alright, so when we plug it into the formula, we get plus and minus 1 divided by the square root of 144. And if you put that in your calculator, you get plus or minus 0.083. Alright, and then the next one, we would actually use that other formula, because notice it talks about standard deviation and things like that. So this one would be plus and minus. The z is 1.96. And then standard deviation is 0.08. And we're going to divide by the square root of 30. Now when I put all that in my calculator, I get plus and minus 0.03. Okay. Alright, so here's what it's actually saying. In the first one, we calculate that 22% said they believe aliens exist. But we're going to add plus or minus 8%, because that's your margin of error. So the true population would be between 14% to 30% actually believe that aliens exist. That's what a margin of error does. And in the second example, we had the GPA was 2.9, but we found the margin of error to be 0.3. So the entire true population would be between 2.6 and 3.2. So you have like a statistic that you calculate, and then you have a margin of error, and then that gives you what the true population would actually be. That's how margin of error works. Okay, so I want you to try this one. So first you need to figure out which formula you would use. Notice that this one's talking about standard deviation, so you're going to be using that second formula. Okay, so for this one, we're going to find our z-score first, 1.96. The standard deviation is 0.9. The population sample size is 900. We put all that in our calculator, we get this. So we found that the mean was 2.3, but our margin of error is 0.06. So if I add or subtract 0.06 from that, I'm going to find that the true number looks like this. So that's how we do these type of problems. Alright, so I want you to pause the video, and I want you to try both of these. So try it in 1, 2, 3. Okay, so for these two examples, you're going to use each of the margin of error formulas. So for the first one, we get 100.18. So what that means is that the actual number will be between these two numbers. Alright, and then for the second one, you wouldn't have to do like a range of numbers because it just says what's the margin of error. Alright, so try C and D. Pause the video and actually try it in 1, 2, 3. So for the first one, you find the margin of error and you get 4.27. If I add or subtract that to the 105.84, oh, sorry, I'm messing up baby sleep. You get that the actual confidence interval is going to be between 101.62 and 110.05. Okay, so for the second one, you're actually going to do the margin of error twice because you're going to do it for public colleges and then private. So try that in 1, 2, 3. Okay, so for public, you get that the point estimate was 9,400, but then the margin of error was 157.16. And then for private, the point estimate 33,410, but then the margin of error is 54.35. Okay, so let's look at some more. So to estimate the population mean, you can determine the minimum sample size needed to estimate the population mean if you have a confidence level and a margin of error. So I'm going to give you the formula. Alright, so here's the formula. N equals Z times sigma divided by big E, which is going to be, hold on, I'll show you what I mean, sorry. And then square it. And then we're going to look at our example. So I'm going to write out what's the important stuff right here. Okay, so here's the 3 things you need to know, and I just got that from reading the problem. And then the z-score, you have to find that. And now I'm going to plug it into the formula. And so here's what the formula looks like, and then I'm going to put that in my calculator. This math is interrupting the baby's sleep, sorry. And then that's my answer. Alright, and then we're going to look at this one. This one is a different. So this is to estimate the proportion in a sample. So I'm going to give you the formula. It looks a little crazy, and then you just need to understand that Q hat is 1 minus P hat. That's an important thing in statistics. Alright, so I know that looks crazy, so let's look at an example and see if you can understand what we're talking about. Alright, so let's do A. We're going to find the minimum sample size needed if no estimate is available. Okay, write out the important information first. Okay, so we're looking at preferring green to blue. So P hat is going to be 0.5 because you have a 0.5% chance of picking up green and then a 0.5% chance of picking up blue. So that's why P hat is 0.5, Q hat is 0.5. Z99 is going to be 2.576, looking at your table, and then E is going to be 0.04 right there. And now I'm going to plug it into the formula. I'm going to plug that all in my calculator, and I should get this number right here. Alright. So now we're going to do part B. So find the minimum sample needed if a previous survey found that 20% of girls prefer green M&Ms to blue M&Ms. So my P hat this time is going to be 20%. Remember my Q hat, if you look on the other page, is 1 minus P. So 1 minus 0.2 is 0.8. So that's how I'm getting those numbers. This one is still going to be the same, and E is still the same. So now I'm going to plug it into the formula. and I get 663.58. Alright, let's do some more. Okay, I'm going to let you try both of these. You can try A and B, and you can pause the screen and do it, and if you get stuck, just push play. So try this in 1, 2, 3. Okay, so I just wrote down like the important information because I'm going to assume that you can plug in stuff into a formula and hit enter by now. But here are your 2 answers. So hopefully you got that right. Let's try some more. So pause the video and try both of these in 1, 2, 3. Okay, so here are your answers for these. If you can't find your mistake, you can ask somebody in your class, or you can ask me for help, or you can go find a tutor, do what you need to do. And then let's do these last 2. So pause the video and try them in 1, 2, 3. Alright, so here are the answers for the last 2. So notice that that last one is a different formula, but it is something we talked about in the video. So hopefully you understand this, and if not, you can go find some help. Alright, bye.